Notice over here on the right, I would just be familiar with these formulas, right? You'll be given them on the test, but make sure you know which one to use when, and kind of the rationale behind them. So to start off, I would just think to yourself, what's the difference between something being disjoint and something being independent? So come up with your own response, pause the video, and then let's come back together. All right, the idea that something is disjoint, think about like your Venn diagram and this being like event A and event B. It means there's literally nothing there in the middle, right? There's no overlap, or the events literally cannot occur at the same time. Okay, if things are independent, it means that they are unrelated, right? The outcome of one does not impact the outcome of the other. Okay, as we go through today, we're going to look at just some different examples and decide which of these probability rules are we using, and then just make sure we can apply it given lots of different situations. So question 1, in a poll, respondents were asked whether they had been in a car accident. 350 respondents indicated they had been, and 450 said they had not been. If one of these respondents is randomly selected, what's the probability of getting someone who has been in a car accident? So out of here, we've got 350 that said that they were, and the thing you got to figure out is the total people we're talking about. So if we add the 350 plus the 480, we end up with a total. Still, the 350 is the people who have been in the car accident out of a total of 380. Then, since it asks us a decimal, we simply divide those, and we end up with 0.45. It says 78. So since that number after the 7 is higher than 5, we're rounded up to an 8. Okay, that was pretty straightforward, and I think you probably just got that pretty naturally. So let's look at the next one. A box contains 6 blue marbles, 5 red marbles, and 2 green marbles. If 2 marbles are randomly selected from the box, what is the probability that? And here, I would also assume without replacement. I probably should have put that specifically in the problem. But we'll do that. That both are blue. So here we've got 6 blue marbles. So we're talking about 6 out of the total marbles, which in this case, I believe is 13. And then another blue marble is we've got 1 less than before because we already pulled out 1 blue, so we got 5. We also have 1 less overall marble, so 12. And then what do we do with those 2 probabilities? We're multiplying it. Think about this as being blue and blue. So as you think about your rules up here, the fact that we are doing and, notice that it tells us up here that we're multiplying. Okay, so as we multiply those 2, if you like it as a fraction, it simplifies to 5 over 26, which is equal to 0.192. 5 over 26, just for you know, is technically 30 over 156. That's an equivalent thing. So if it says report as an unsimplified, they're actually probably talking about that fraction. But either way of these, I would say I'll accept either one. Do not stress too much as to the format. Okay. What about if the first one is red and the second is blue? Well, there are 5 red marbles out of a total of 13. And there's still going to be 6, because if the first one we pick out is red, it doesn't affect the blue, but now we'll only have 12. So we multiply those 2, once again, we get the same exact probability. That 30 over 156 also reduces to 5 over 26, or 0.192. Okay, let's look at the next one. We got some Christmas lights now. So, Christmas lights are often designed with a series circuit. This means that when one light burns out, the entire string of them goes out. So suppose that the lights are designed so that probability the bulb will last 2 years is 0.995. The success or failure of a bulb is independent of the success or failure of the other bulbs. So, what's the probability that a string of 10 lights, all 10, will last 2 years? So the probability that the last 2 years is that 0.995, and if we've got 10 of them, you can think about it as we're multiplying that 0.995 10 times, but the easier thing to do is raise it to the 10th, and when we do that, we end up with 0.951. Okay, what's the probability that at least one will burn out? So think about that, and thus the entire data strings will go out. So the probability that at least one burns out. So that means that either 1 burns out, 2 burns out, 3 burns out, etc., right? So it's easier, rather than doing the probability of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's easier to say this is the same as doing 1 minus the probability that none burn out, right? The opposite of burning out is none burn out. So we get 1 minus, if none burn out, that's the same as saying they all last, right? And guess what? That's what we figured out in part A. So we're doing 1 minus 0.951. So we end up with 0.049. Okay, let's take a look at the next few. Okay, I will say on my little Quizlet today, I couldn't put any two-way tables on, so make sure you pay attention to this one, or maybe pause the video for a second, try to do it yourself. But we're talking about managers being rated as good, fair, and poor, and then their educational backgrounds too. So, if a manager is selected at random, what's the probability they're giving a rating of fair or poor? So we're just looking at the totals for fair and poor, or poor. So in this case, they could be either one, so we add those two probabilities. Still out of that total, though, overall of 160, so we end up with 121 over 160. And in this case, they said you can leave it as an unsimplified fraction, so I would just leave it as such. Notice here in this case, we don't have to subtract anything for both of those, like and poor, because the probability there is 0. They're disjoint events. Someone cannot be both fair and poor. So next, let's look at B. If a manager is selected at random, what's the probability that they have a high school degree or were given a rating of good? So this time, maybe let me change colors up here. So if they have a high school degree, we got 17 of them, right? A rating of good, we've got 39. So we usually just add those for ors, but notice here that you got these 8 people that were counted in both categories. So that's when we subtract those 8 people, and we still do it out of a total of 160. So we end up with 48 over 160. And you can leave it like such. Okay, let's look at the next one. This one says if a manager is selected at random, they are rated as a fair manager. So we're only talking about this group here of fair managers. What's the probability that they have a master's or PhD? So now we're just talking about the master's or PhD. We're talking about the 25 of them out of the 87. Notice this is like your conditional probability. So remember, like another way that you could say that is like, given that someone is a fair manager, what's the probability that they have a master's or PhD? So be careful when you're doing it over the row or column total versus the overall total. Okay, let's look at the next one. The next one says, in how many different ways can a ski club consisting of 20 different people select its officers? The positions available are president, vice president, treasurer, and secretary, and no person can hold more than one position, and each office is filled once the order is selected. So notice here you've got 20 different people, and we are choosing 1, 2, 3, 4 people for the president, vice president, treasurer, and secretary. So now all you got to ask yourself is, does order matter? Order matters, question mark, and the answer here would be yes. So therefore, we're doing a permutation. Once you've got that, remember it's just your trick of typing that in your calculator, and you should end up with 116,280 different ways. All right, I suggest now doing the Quizlet just to get some more practice, or you also have a homework assignment on 5.6 to make sure that you know exactly how to apply all these different situations, not just practice one skill at a time with